Okay, so yet another way to assess the importance of different variables in our model is to use something called the minimal depth. Now, I know that sounds maybe kind of complicated, but it's actually very, very straightforward what this thing is. Okay, and the idea basically is that the closer to the root node a variable appears on a tree, the higher up a variable appears on our tree, the more fundamental it is. Okay, so for example, in our Titanic data set, and when we fit that decision tree, what we found was, generally speaking, the first split is based on gender, and then often the subsequent split was based on the passenger class and the age. Okay, so what that suggests is that gender perhaps is the most important or the most fundamental variable that determines whether or not you survive on the Titanic. First, you got to figure out what the person's gender is, and then given that they're a man or a woman, then you ask what is their passenger class or what is their age. It's a bit like playing the game of 20 questions, right? If you play a game of 20 questions, the first question you might ask might be, okay, is the thing that you're thinking of, I don't know, is it a living thing, right? And of course, that's a pretty significant question because based on what their answer is, that's going to really change your subsequent questions, okay? Now, by the time you get down to like the 19th question and you're asking them, okay, is the object blue or teal? You could argue that maybe that isn't quite as important. Okay, so it's the same idea here. The first split, whatever variable is sort of higher on the tree, the more important it is. Okay, so the minimal depth of a given variable, it answers that question. Okay, you see, the minimal depth of a variable is simply the shortest distance between the first time a variable appears in our tree and the root of the tree. Okay? So for example, the variable age in this tree has a minimal depth of 2 because to go from age to the root, you need to sort of skip 2 places. So I'm going from age, okay, so I go to passenger class, that's 1, and then go to the root, that's 2. Okay, the minimal depth of passenger class is 1 because it's just 1 away from the root node. And finally, sex has a minimal depth of 0 because it is the first split. It is the root node. Okay, so I hope that makes sense. Let's go over to R and see how this is implemented. Okay, okay. So in order to measure this, we actually need to use another package called the Random Forest Explainer package. Okay, so go ahead and install this package. This package, it takes a little while to install. Okay, but go ahead and install it, and then load it up with library Random Forest Explainer. Okay, and then what you're going to do is you're going to run this command: min_depth table equals min_depth distribution. You're going to call this min_depth distribution function on your random forest. Now, this function will take probably a couple of minutes, maybe upwards of 5 minutes to actually run. Okay, so run it on your computer. Just kind of sip some coffee. Ponder the meaning of life while it's running. Okay, computer's doing all the hard work. You're just telling it what to do, and then after it runs, finally, okay. You're gonna get this. We're gonna save this thing to a table, min_depth table, and then we can have a look at the table. So I've already run it, magic of television. Okay, so let's have a look at this min_depth table. Actually, let me just open it up. I'm going to click on min_depth table and open it up bigger here. Okay, and you can see. So what's going on here? So this is the minimum depth for the first tree. Okay, so here's tree number 1. And it tells us the minimal depth of each variable. So minimal depth of bathrooms was 0. So apparently in the first tree, bathrooms was the root node. It was the most important variable, at least by this metric. Okay. New construction, however, has a minimal depth of 12. It's very far away from the root node. Okay, so at least according to that first tree, new construction wasn't very important. Now, of course, it goes through and it measures the minimal depth of each variable for every single tree in our random forest, and we have 500 trees in our random forest. So this is a pretty big table. Okay, having that table isn't so useful. What we really want is kind of the average minimal depth across all the trees for each variable. Okay, and we can get that as well as a nice looking graph if we call this function, plot min depth distribution on the minimum depth table. So this command doesn't really take very long to run at all, just a couple of seconds. Okay, and you can see here's my plot over here. Okay, and what this is saying is that on average, living area, it seems, has the lowest minimal depth across all of the trees, with a minimal depth of close to 1 on average, followed by land area, followed by the number of bedrooms, followed by the age. This looks kind of familiar. You'll see that actually this measure, at least for our data, is pretty consistent with the two other measures of variable importance we've looked at so far, the ones that involved omitting or scrambling one of the variables in question. Okay, so this is yet another way to measure the importance of a given variable, is to look at the minimal depth.